let's take a look at page 6. When will oxidation happen? So oxidation usually occurs when the oxidation state of an element increases, and reduction happens when it decreases. So if you take a look at this, right, it tells you that if I were to give you this equation that you see below you, what you need to do now is actually you need to determine whether or not the oxidation state did change for each of the element. For instance, if you look at this hydrogen, okay, it's an element, right? H2 is just a hydrogen element. The oxidation state is 0. For oxygen, it's just a pure element. The oxidation state is also 0. But if you look at water itself, it's a compound, right? There's an oxygen inside, and this oxygen will have an oxidation state of, do you remember what's the oxidation state of oxygen when it's in the compound? Yes, it's -2. And this hydrogen will actually have the oxidation state of +1. And there's 2 hydrogens, so total is +2. And you balance up the +2 and -2. So you get a compound that has no charge on its surface. Now if you take a look at this, right, you realize the hydrogen, initially the oxidation state was 0, it went to +1, right? You see an increase in what we call oxidation state. And there is therefore a type of oxidation, just with a bracket O. On the other hand, you realize that for the other one, oxygen, it actually went from 0 to -2. So this is a decrease in oxidation state, and we term it reduction, so I put a bracket R. Now, with that in mind, let's take a look at how do we determine in some of the other examples. So, take note that oxidation is when oxidation state increases, reduction is when oxidation state decreases. Now, this is in addition to what you done just now as the ox-go-lay. In the ox-go-lay, you can use by gaining of oxygen. You can also look at whether is it losing or gaining of electrons or hydrogen. But the key thing that you really must pick up from this entire topic is how to use oxidation state to tell whether oxidation happens or not. So there is one more method. So this is method 1. You can look at oxygen. Method 2, look at electrons. Method 3, look at hydrogen. And method 4 is in oxidation itself, right? The oxidation state increases. So these are the 4 ways to tell whether oxidation happens or not. And reduction will be the opposite. So let's take a look at some of the examples. Okay, in example 4, you realize that, now it's the same example that we talked about just now. Actually, if you just look at it and based on what you learned previously, right, it's actually very easy for you to tell whether it's being oxidized or not. Because you look at it, right, you realize that the magnesium actually gain an oxygen, right? So from what you know from your ox-go-lay, this is oxidation. Now, but the question is a bit unique in the sense that I only want you to explain in terms of changes in oxidation states only. So you cannot talk about whether it gain or lose oxygen, whether it gain or lose hydrogen or electrons. I just want you to look at the oxidation state. And that will be the case in the exams or tests, whereby we only want you to explain in one of the 4 methods. And more often than not, the method is usually to explain based on oxidation states. So let's take a look at how to deduce the oxidation state. Magnesium is an element, so the oxidation state is 0. Oxygen is an element, so same thing, the oxidation state is 0. But in magnesium oxide, because it's a compound, right, you should know that oxygen, the oxidation state inside is usually in the compound is -2. Whereas magnesium, in this case, to balance out the charge, will be a +2. In fact, you should already know that magnesium is a group 2 element, so it should be +2 lah. Okay, so looking at this, right, you realize that, the oxidation state for magnesium, for instance, it went from 0 to +2. And the one from oxygen went from 0 to say -2. So this will clearly tell you that, whether oxidation or reduction happens or not. So, like what we mentioned just now, oxidation is when you increase the oxidation state. So this is your oxidation. Reduction is when you decrease the oxidation state, when you go from 0 to -2 in this case. So how do you explain? Very similar to what we explained previously, substance that's made oxidized is Mg, the reactant, because the oxidation state, okay, of magnesium has increased from 0 to +1 in MgO. Now, a few things I want to add in. The format should still be the same. We need to talk about before, after, and what happened. So of course, what happens is this: the oxidation state increases from whatever number to whatever number. But remember, we must mention that this 0 was when it was in just Mg. So the oxidation state of magnesium has increased from 0 in Mg to +1 in MgO, for instance. And the substance that's being reduced in this case is your O2, because, same thing, the oxidation state of oxygen has decreased from 0 in O2, okay, what was it previously in, to -2 in MgO. Alright, so that's how you tell. I realize there's another error. Can you change this to, instead of +1, it should be +2. Okay, because magnesium now is +2 already, the oxidation state in MgO. Alright, so that's how you explain. Likewise, I have the what exactly happened in this reaction. So oxidation state in this case decreased from what number in whatever substance to what number in whatever substance. So that is how you should explain based on oxidation state. Shall we take some time to try out the remaining questions? Same thing, pause the video, and after about 5 seconds I'll show you the answers over here so that you can double check. Alright, the answers for the practice question B and C. Okay, by now you have noticed that sometimes in oxidation state, right, you actually have to work out for everything, and not everything will change at the end. What do I mean by that? If you take a look at B, right, maybe most of you will get the same answer as me, right, but some of you, if you think a bit deeper, you realize that, hey, the oxygen, right, at the start, it was a -2 per oxygen, right, because when you talk about oxidation state, we always count by each of the atom. At the end, it was still a -2, so nothing actually happened to the oxygen. And that is actually okay. Doesn't mean that every time in a reaction there must be oxidation and reduction, or sometimes there is no oxidation and no reduction and nothing happens, right? So there's something for you to think about. It need not necessarily means that every time when there's a reaction you will expect everything to have its oxidation state changing. That is the reason why you need to practice how to determine oxidation state, so that you become so good at it that next time you can just straight away deduce it from the start. So your chromium, because each of the oxygen is actually -2, there's 3 oxygen, so total is -6. So the chromium, the two of them should give you +6. That means each of the chromium should be a +3. Aluminum here is an element, so it will be 0. Over here, aluminum is actually a +3. Over here, chromium as an element, it will be 0. So what you notice is that the oxidized substance, right, is actually aluminium. And just to briefly talk about what we always used previously, oxidizing agent and reducing agent. Because aluminum is oxidized, right, we actually call it the reducing agent. Okay, because it's being oxidized, it might have caused something else to be reduced, hence we call it the reducing agent. Whereas the chromium oxide, the Cr2O3, is what we call the oxidizing agent. Okay, another interesting thing that you might have noticed is that we say that it is the reactant, the entire Cr2O3, that's being reduced, although it is only the chromium inside that has gone through a change from +3 in Cr2O3 to 0 in Cr, right? But that is the case because when we talk about what is being oxidized and what is being reduced, right, this substance word that we use, this substance, right, we're actually referring to the entire reactant, the entire chemical at the start, the left side of the reaction. So we always talk about that. So it's the entire thing as a chunk, which is in this case is Cr2O3. But of course you should be able to deduce that only the oxidation state of the chromium inside has undergone a change, because like what I said, the oxygen, actually there wasn't any change, and that should be the case, no issue with that. And of course when we answer, right, there's always the format. What happened to the oxidation state? In this case, it increased from what happens previously to what happens after that, right? So it's always the same answer. Even if you look at C, it's also the same case. Oxidation state increased from 0 in Mg to +2 in MgO. Oxidation state of hydrogen decreased from +1 in H2O to 0 in H2. So all these things comes with practice, and you do need to have the 5 rules with you every time you do these questions first, until you get used to these 5 rules and you should be able to do it by yourself. So very quickly, just to end it off, if you look at part C, which one is the reducing agent? Is it the Mg or the H2O? Yes, the answer is the Mg, because it is being oxidized. Alright, with that we have come to the end of this lesson, and feel free to try out the 10 series questions on your own to determine the oxidation state. I'll see you when the holiday is over. Bye bye.